Okay, guys, as I said, I'm gonna explain to you how to optimize the quality of the signal and what do you need to do to amplify if the signal is very low quality or power is very low. The signal amplifying, however, it's coming with a big downsides. The more the signal you amplify, also you amplify the errors. Right now, I'm going to explain how to do the signal amplification and also how to achieve signal amplified with error correction. Because if you amplify the signal, automatically the error is also amplified. For doing a signal optimization to make sure that the signal is going well, you're gonna need a device such as this one, a signal meter, which is able to do the measurement like power, like MER, CBER, and a useful signal, and also here in the left side of the corner here, 0 uncorrected errors, because here in the uncorrected errors it will show you the quality of your signal. The aim to get quality signal, it's to get as less error as possible. I mean, if possible to achieve 0, it's perfect. But there is also a tolerance. You can achieve, for example, a very good useful signal with a tolerance of plus 100, maybe up to 200 uncorrected errors. Whatever is going over 200 uncorrected errors, they will be you will see them and sense them in your application which you are using with the DVB cards as TS errors. So if on your signal, on your input signal, uncorrected errors is 0, then your reception is 100% perfect. If you have uncorrected errors value of 100, maybe up to 200, it's still correct. I mean, it's still okay. The image is crystal clear. But if the uncorrected errors are going over 250 to 300, then you're gonna receive TS errors, and of course your reception is going to be blurred, the image is going to be blurred, and macroblocks and all kind of garbage stuff in the reception. To amplify a signal, you're gonna need a such device. Why is this amplifier is important, and why you need to make sure that it has attenuator and equalizer? Because with attenuator and with equalizer, equalizer you can reduce, you can increase or decrease the signal power, and with attenuator you can correct the errors, the reception errors, the garbage which is coming on the signal. Pretty much similar stuff applies to satellite. This setup is prepared for cable. Pretty much the same setup applies for cable, for satellite, sorry. But the only difference is in the satellite cards, you need to provide in the roll-off field the exact values of the roll-off. So the DVB card, the tuner, to be able to correctly register the signal and manage the signal. So this is it. This is the amplifier, yeah, and this is the measurement tool. So I'm gonna move the how it's called, the provider cable into the amplifier, yeah, and I'm gonna plug the amplifier into the measurement device. Right now everything is on 0, and we have 255 errors, and the signal is bouncing. I'm gonna show you I'm gonna increase the signal right here. I'm gonna increase the signal until we get useful signal and we are getting reception. It's a slow process and you need to be very careful because it's very sensitive. It has very sensitive capabilities. So once you do the attenuation, you're gonna see firstly the signal, it will drop a little bit. yeah, it will drop to 74 from 80, and it's gonna start bouncing with a lot of errors. See, these are the uncorrected errors I wanted to show you. My cable already, it's having this entire process, it's applied, my signal cable. So I just wanted to simulate to you and show you the uncorrected errors. These uncorrected errors, it will show you, it will display you as garbage on the signal reception. So to correct now, we give some attenuation, and we're gonna play with the equalizer of the signal, and we're gonna try to equalize a little bit the signal. So I'm gonna show you immediately as I will start rolling the signal equalizer. Yeah, the errors will start decreasing. This is a simulated situation because it's already it was already, how it's called, done. Now the trick is the following: as higher as you go in frequency, for example, for frequencies starting from 500 to 6 or 700, the level of uncorrected errors is growing. The lower the frequency is going, the level of errors and number of errors are decreasing. So that's why channels or content from low frequencies are usually how to say less, with less errors than those one from how it's called, from higher frequencies. As you can see, when I started this measurements, I was starting with a 80 signal, and now I'm back to 68, but there were 65,000 errors. Still sometimes it shows, but tinkering the attenuation and the equalizer on the signal amplifier, it will allow me to decrease from 65,000 errors to 27,000. And this is the whole process. You have to repeat, and you have to measure, and you have to tinker a little bit on the signal amplifier, on equalizer, and on attenuator, so you can get the useful signal without uncorrected errors. As low as the error you will receive, the lower the error you receive, the better is the how it's called, the reception on the cable. Don't forget, I already mentioned, in satellite reception it's pretty much similar. You can hook up a amplifier and the signal analyzer, and if you have an amplifier with a equalizer or signal attenuator, you can tinker, and you can correct the errors of reception. Correcting the error of reception and removing and making everything to remove the uncorrected errors, it will translate on very good quality of the image and very high and big stability of reception. Pretty much this is it. I'm gonna explain more in my next movie, because we're gonna try to replicate a similar measurement with satellite with a satellite setup. Thank you very much. Enjoy, and bye bye.